So let's move toward our next topic, which is multiplication of complex numbers. Now let's say we have two complex numbers, z1 equals a plus b iota and z2 equals c plus d iota. We need to multiply these two complex numbers z1 cross z2. So when we multiply these two complex numbers a plus b iota c plus d iota, we will use the rule. Similarly, we will multiply a with c and again we will multiply a with d, same as we will multiply b with c and b with d. So let's do this. z1 cross z2 equals ac plus ad iota plus bc iota plus bd iota square. Iota will be multiplied by iota and it will become iota square. As we know that from previous classes, iota square equals -1. So when we solve this, we will have ac plus ad iota plus bc iota minus bd. So further solution, ac minus bd plus, take iota common, ad plus bc. That's the required solution. Now let's solve an example to get a better understanding. Let's say we have two complex numbers, z1 equals 2 plus 4 iota and z2 equals 3 minus 3 iota. Now we need to find the multiplication of these two complex numbers. So let's do this. So let's say we have z1 cross z2 equals 2 plus 4 iota and 3 minus 3 iota. So we are going to multiply 2 with 3 and similarly 2 with minus 3. 2 times 3 equals 6 and 2 times minus 3 equals minus 6 iota. Similarly, 4 times 3 equals plus 12 iota and 4 times minus 3 equals minus 12 iota. So now we have 6 minus 6 iota, 4 multiplied by 3 becomes 12 iota square, as we have 4 iota and minus 3 iota. So plus 12 iota minus 12 minus 1, as iota square equals minus 1. So 6 minus 6 iota plus 12 iota plus 12. Now we need to add a real part with a real part and imaginary part with the imaginary part. So we will have 18, 12 plus 6, 18, so 6 iota. So the required solution is z1 cross z2 equals 18 plus 6 iota, and that's our answer. Now let's move toward our next topic, which is division of a complex number. Let's say we have two complex numbers as z1 equals a plus b iota and z2 equals c plus d iota. The division of a complex number z1 divided by z2 equals z1 over z2 multiply the conjugate of denominator z2 conjugate divided by z2 conjugate. We will multiply and divide by the conjugate of this complex number z2. So here's the trick. Now z1 over z2, let's put the values, equals a plus b iota over c plus d iota. Multiply the conjugate of z2, c minus d iota, divided by the conjugate of z2, which is c minus d iota. So In this way, we find the division of complex number. Now let's solve an example. Let's say we have two complex numbers, z1 equals 4 plus 3 iota and z2 equals 1 plus 2 iota. z1 over z2 equals 4 plus 3 iota divided by 1 plus 2 iota. As we said earlier, we will multiply and divide by the conjugate of this number. So we will have 1 minus 2 iota and 1 minus 2 iota, multiplication and division. Now we need to solve these equations. So when we multiply these two, it becomes 1 square minus 2 iota square, and here we'll use the same multiplication rule. 4 multiplied by 1, 4 multiplied by 2 minus 2 iota, 8 iota, 3 multiplied by 1, 3 iota multiplied by 1, so plus 3 iota, and 3 iota multiplied by minus 2 iota, minus 6 iota square. So from here we have 4, as we know that iota square equals minus 1. So 4 minus 8 iota plus 3 iota minus plus 6 over 1 minus 4 iota square. So now we have 4 plus 6 plus iota, take iota as common, minus 8 plus 3 divided by 1 plus 4. So we will have 10 plus 8 minus 3, so iota, and here we have minus 5 over 5. So 10 over 5 minus 5 iota over 5. So the answer will be 2 minus iota. So the division of z1 divided by z2 equals 2 minus iota. Here is the solution. So that's how we divide two complex numbers, z1 and z2. Now let's move toward our next topic, which is polar coordinates of complex numbers. Let's say we have a complex number as z equals x plus iota y, which we can write in coordinates form as x comma y, and as we studied that this can be represented on Argand diagram. This is positive x-axis and this is positive y-axis. So let's say we have here x and here y, and that is the point where these two points join each other. So this is the line joining the point and origin, and this is the y, and similarly this is x. This is angle theta, and this is r, the modulus of this complex number. As we represented this complex number on Argand diagram, now we can have cos theta equals x over r. As you know this statement from your high school, as some people have curly brown hair till painted black. So we have sin theta here perpendicular upon hypotenuse. Similarly cos theta here base upon hypotenuse, and tan theta here perpendicular upon base. We will use the same principle here. So when we are going to find cos theta, this is base over hypotenuse. So from here we have x equals r cos theta. This is the value of x. Similarly, now we will find sin theta equals perpendicular upon hypotenuse. So perpendicular we have y over r. So when we solve it, we will have y equals r sin theta. Now put these values in this complex number. So let's add another page. So we will have the equation as z equals x plus iota y. Put the values of x equals r cos of theta. So r cos theta plus iota r sin theta. Take r as common, so we will have cos theta plus iota sin theta z. This is the most important result, and this is the polar coordinate of complex number. That's how we represent it. This is polar form of a complex number z. Now let's solve an example to get a better understanding of this topic. Let's say we have an example which states as find the polar coordinates of z equals 1 plus iota r theta. We need to find r theta first of this complex number. So when we are going to find r, what's the formula? Real part of z square plus imaginary part of z square whole under the root. So put the values in this formula. So we will have r equals, what's the real part? Here 1, and what's the imaginary part? 1. So 1 square plus 1 square whole under the root. So we will have under root 2. This is the value of r. Let me write it here. R equals under the root 2. Similarly, we will find the value of theta. So the argument of a complex number theta equals tan inverse y over x, where y is an imaginary part and x is the real part. So what's the imaginary part? Tan inverse is 1, and also the real part is also 1. So theta equals pi by 4. That's the value of theta. Now we have the value of r and value of theta. Now we are in position to find our polar coordinates of this complex number. So z equals r cos theta plus iota sin theta. Z equals, put the value of r under root 2 cos, what's the value of theta? It's pi by 4. Pi by 4 plus iota sin theta, what's the value of theta? It's pi by 4. So that's how we solve it. This is the required solution. Now let's move toward our next topic, which is exponential form and Euler formula.